Now, question 26 is a little bit difficult to understand, but let me try to explain it. First of all, the radius 2 is 90% of R1, so it's 0.9 R1. That's clear. And since the area of cross section depends on the square of the radius, this means that A2 would be the square of 0.9, 0.81 pi R1 squared. So using A1 V1 is equal to A2 V2, we can prove that V1 is 0.81 V2, or V2 is 1 by 0.81 V1, right? Which is 1.23 V1. Now from Bernoulli's principle, you see that the difference in pressure is directly proportional to the difference in the square of the velocities. So if you take the square of V2, you get V2 squared is this. Plug it in place of V2 squared there, and you would get that the change in pressure is proportional to 0.52 V1 squared, which is 52% of the original. So that's the answer. Now on 27, which is a direct question, R1, R2 given, P1, V1 given, you got to find P2, V2. Use the equation of continuity and find the velocity, and then use Bernoulli's principle as illustrated here to get the final pressure of 6.417 kilopascal. In 28, torque is the cross product of R and F. So all you need is put the I, J, K vectors, write down the components, and just take the cross product. Just remember that when you take the cross product of I, you go 4 times 3 minus the product of these two, which is plus, so you get a negative there. So that's why it's 8i. And then it's negative j, and you take the product of 3 times 3, and same thing, and you get the answer. 29 is a direct and easy question, because first you can find the rotational inertia using I is tau by alpha is 2.10, and then I is mr squared by 2 for a disk, so substitute that and you would get the mass of 16.84 kilogram. Question 30 is, it's not simply friction is equal to mu times the normal reaction, which most people would do. In fact, you don't even use the normal reaction and the coefficient of friction here. When you look at the figure, you see that there is a force here, that's the reaction from the wall. There is a normal reaction. There's friction against the direction of slipping. And if you just from this triangle, you can get x is 1.36 meter, easily understood, because these two are given. X squared is just 2.5 squared minus 2.10 squared, and you will get that. Now, if you take the moment about A, then Fn and Ff will not have a moment there, cancel out, and so the counterclockwise is F times 2.1, because you got to take the perpendicular distance between F and which is this one. So, and then 98 times the perpendicular distance, which will be half of 1.36. Then 784, which is almost at the end, times the whole distance, 1.36. And you would get F as almost 540 newtons. And because the sum of the forces along any axis must be 0, you know that friction, which is along the positive x-axis, must be the same as force on the wall, which is along the negative y-axis. And therefore, the force of friction is 539.46 Newton. Thank you.